Hello everyone, let's do this. February 26th. Let's take a look at today's daily challenge. Before we do that, same old thing, take a look at the notification. I don't remember when I commented on this a long time ago. Alright, so nothing to worry. Okay, we're gonna go to our question. 1, 2, 3. Validate stack sequences. Okay. Given two sequences push and popped with distinct values, return true if and only if this could have been the result of a sequence of push and pop operations on an initially empty stack. So we're going to validate if it is... I think I've done something similar in my undergrad class. Not 100% sure. Let's take a look. So we have push 1. So do we do all this? And then we pop? That's it? Oh. So we just do that. We just push these into a stack. We don't even have to push these into the stack. We just... Oh, hold on. Oh, it's not in this... Wait, is that not in this order? Do we have order here? We have two sequences, and this could have been the result of a sequence of push and pop on an initially empty. So push 1, push, and pop. And push and pop, and pop. I see. Alright, it's more complicated than I thought. It was just, you just check. No. So what we're saying is we don't know when the push happens or when the pop happens. What we know is these numbers have been pushed into the stack and the other numbers have been popped out of the stack. And that's the only thing we know. But we don't know when or how, which one does before the other. We know that push must happen initially, right? Because you cannot pop from an empty stack. So we're going to push first, but after the first push, we don't know if it's a pop or if it's another push. We don't know that. And let's take a look at the specification. We have 1,000 for each one of them, hinting at most going to be n squared. Pushed is a permutation of popped, and they have distinct values. Okay, so which means if we decide to pop a value that is the same as the current is like on the top of the stack, then we're good. So we can create, right? We can create a stack. And we're going to push. So we push 1 into it, and then we're going to check the front of the pop. And if the front of the pop is not the same as the top of the stack, that means that pop cannot happen. So we keep pushing. We're pushing 2, now the same, pushing 3, now the same, pushing 4. Now the top of the stack, we don't even need to be top of the stack. We just need two pointers. One pointer for the push and the other pointer for the pop. And then we're going to move the pointer on the push just one by one at a time. And every time we move, we check the top of the pop. We're going to do this so the top of the pop will not move until the pointer on the push moves towards the value that is the same as the top of the pop. When they're the same, we know we can pop. So when they're the same, we're going to move the pop pointer one increment to the right. And then, for example, let's just take this as an example. So we have a push. Let's just call this I. This is J, right? So pushed I is not equal to popped J, so I increment. Still not equal, increment. Not equal, increment. Now we're equal. Whenever it's equal, popped is going to increment. When pop increment, they're not equal, so I keep going to 5, and they're equal, then I go to 3. And once I go to 3, how do we do this? Do we just keep going? I kind of feel it's not correct, because how Oh, when we pop, do we have to move backwards? And then we have to skip forward. Might as well use another stack. We're just pushing. Because like at 4, right? And then we say we pop. And then we can move this one forward so we know the next one we need to pop is going to be 5. But here, I'm here, right? So I have pushed 4 and I have pushed 1, 2, 3. Which means like if I change the order here, change it to 1, 2, 3, how am I supposed to know? So in order to know, we do have to, maybe there is a O1 space solution, but right now, as I'm thinking about it, the best I can do is ON space. So we actually have a stack, and then we push, 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 right? Push, and every time we push, we check the pop, and now we're the same. So pop move on, and this gets popped, actually gets popped. So we now at here, and next one is 5. It's not the same, so we keep pushing. If there are more, so we push 5 in, and then 5 are the same. So 5 gets popped. Just move on to the next one, and there's nothing, right? A nothing. Then we just go back to look at the top. They're the same, so we can pop, same pop, same pop. And here this is not correct because I can do push, 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 and then they're the same. And pop. And then after pop, we need to check if they're the same. They are the same, pop again. And then they're not the same because we want to pop 5. Currently we're at 2. So we go next one, we push. So we push 5, and after push, we check. They're the same, so we can pop. Now we want to pop 1, but we're at 2. But we cannot pop 1 because 1 is not there. And we try to find if there are more that we can push. But nothing more. So push is ending, push has ended, and the top of the stack is not the same as the current pop value. So we say it's false. Okay, let's try to write this into an algorithm. It's actually a little bit more complicated than I was imagining earlier, because it seems to be a couple loops. I mean, we won't know until we start doing it, and then we can get some intuition. It happens all the time with me. You know, you have a vague idea, like, and I think that might work, but as you start writing it out, it seems to be a better, you know, ideas gets better. So maybe it is also better to have 2 pointers, right? I am going to have 2 pointers, so the for loop seems to be a little bit hard to reason with. So let's just have 2 pointers. And what we're going to do is we're going to have a forever loop, because I'm not sure how the end situation is going to be. And we're going to have a stack, right? This is to help us. All right, we're going to say if I is 0, which means this is a starting point, or popped j is what if the popped j is equal to the front at the very beginning, and that should be false, right? No, that is true, because we can push 1 and we can pop 1. So, oh, sorry. What I'm saying is, it is possible to do, let's say, 1 and 1, right? So like 1, 2, and 1, 2. This is possible. This is true. I push 1, we pop 1, push 2, pop 2. Yes, so it has to be, if I is 0, we would definitely push, or when we push is the front is not equal to pushed I. So actually, we can do this. If they're not the same, which means the current value, oh, it's actually not pushed. It's going to be your stack. So if not stack or j not equal to stack, the top of the stack, because if it's equal, then we can pop. So if it's not, then what do we do? So it's not stack or this, and actually we need another one. So if it's not stack or it's not equal, and we have more value to push, all right, let's code it down so we can fix the logic later. So this means we are open to push. So we're going to check another one. If I is smaller than len pushed, then we do stack dot append pushed I. That's it, right? And if it's not, then we don't push. So we do the push. We need, so after we push, I need to increment, right? I need to increment, and then we need to continue, and then we can say else. That means popped j is the same as, so the push might happen first, then pop. So we can actually walk the pop. So the condition here will be j is smaller than len popped, right? So if they are the same, the current value to be popped is the same as the top of the stack. Then what we do? Then what we do is we're gonna call stack.pop because it's popped, and we're gonna increment j, and then we keep going, and then until we end. Now, how do we end? If it's right, then we will end when j is ending, right? If it's this situation, what we have a current one is we do not have another one to push, so we get stuck in a forever loop. How do we get out of the forever loop? So else, so if the top is not the same and there's no more to push, we call it false. So we still have j, we still have something to pop, but we don't have anything to push, and the top and the current to pop is not equal to the actual value on top of the stack. We call false. And if everything works, and we call true. Alright, this is the logic. Let's take a look at the test cases. We have 3 test cases. The first 2 are given by the question, and we can try it here. Okay, we have 1, 2, 3, 4, 5 again. So this one is 4, 3, 5, 1, 2, and this one is false. And then we also tried some like 1, 2, 1, 2. This is going to be true. And an edge case, which is empty and empty, this shall be true. Or we have the permutation, so that's the only possible. So let's change this as well. So this is going to be pushed and popped. And this one is going to be validate stack sequences pushed, popped. Boom! All pass my test cases. Let's take a look at here. Submit. We did it. It's probably an easy question. Very straightforward. Yeah, All right, we now are gonna write a lot about this. My favorite sentence: straightforward solution. We use a stack to maintain the current stack state based on the pushed list, and we check whether the top of the stack matches the current value to pop. If the two matches, we increment the pointer on pop. Otherwise, we keep pushing. A false return happens when the top of the stack does not match the current value to pop, and we have exhausted all values to push. This is going to run in O(n). Well, it's O popped. Right? It's going to run the most O. I say O popped. And then we had it at 72 milliseconds. 63% ranking. I'm still thinking whether it's possible to not use a stack. We just do some pointer manipulation. We probably am able to do this. Let's count it as a medium question. I'm not sure about that. I think it's a medium easy one, but maybe O1 is a bit harder because we have the pointer, right? So every time we pop, we can just move back. But the thing is, if 4 is popped, right, and we move back, and then we want 5, and then I need to keep moving forward. So we just have 2 pointers then. One pointer is always going forward, and the other pointer will stay where the current top of the stack is. So we have 2 pointers. Initially, we keep moving at the same time, and when we pop, one of the pointer goes back, and the other pointer goes forward. And then we push, and then this one will merge to here, and then when we pop, how do we escape? We can invalidate this value. So we have the value is from 0, so we put it as -1. When now we pop, we do -1, and we just go backwards. It's -1. We return at the first value that is not -1. I mean, the total operations is the same. It's the same number of operations. We just don't have any pushes, right? But if we do a -1 as a flag, is it possible to use only one pointer? So we go here, 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 and then when it pop, so we set it to -1, and we're going backwards. And they're not the same, so we're going to keep going to see if we have another one. We have another one, good. So we're currently pointing here, and then because they're the same, we are going to pop it, so to -1, and we go backwards, and then we have a lot of forward and backward movement, right? And we have a lot of forward backward movement, so probably not as efficient. All right, let's take a look at the solutions. Let's see. First one, greedy. We have to push the items in order, so when do we pop them? If the stack has 2 at the top, and if we have to pop that value next, we must do it now. A subsequent push will make the top of the stack different. Yes. So we create a stack, and then we keep pushing, And while stack and j is good and is equal, we're gonna pop j. And oh, we count. Oh, okay. So this one is a for loop. Same idea. Same idea. We have two, so they only need one. But the idea is the same. That we keep pushing, but every time we push, we're gonna check on the pop. And if it's not the same, we keep pushing. If it is the same, we just keep popping until we hit one that's not the same. And then every time we pop, we count how many values we have popped so far. So this is good. And that's it. All right, we can, so this is actually looking from a different angle. So we are looking at the J angle, right? This is looking at, when we're looking at the popped angle, this is looking at the pushed angle. Let's take a look. O1 space, yes. That's not O1 space. Oh, that's simulating, okay. Using push as stack, yes. It also changed, yeah, it does change, you have to change the input. Yeah, it's the same idea, but you have like another loop inside. I think this is exactly the idea that I had, right? If I larger equals 0, and then we manipulate I and j. Okay, we're going to read this. I'm going to read this again. So for x in push, we're going to pushed, and push I equals x. Okay. Oh, it's a stack. So while I is larger than 0, so we are popping, and then they're the same, and we pop, so we pop, which means this goes back, this goes forward, and after that we go into increment. That's the next one. Oh wow, wow! This is very smart. This is very smart. I mean, that's not his solution. It's somebody else's. But you can achieve O1. You're changing the input. I think I'm going to code both. I think there's nothing else to see. 2 pointers simulating. Alright, so I'm going to try these two solutions. So one of them is to basically, I mean, they're all the same. They're all very similar solutions, but this one will be to view on the, so when I say count pop, make it more explicit. So I'm going to say for P in pushed, right? So we're going to just keep one by one on the push. So this is saying we are looking from the perspective of the pushed, and the previous is looking from the perspective of pop. So on this, for everyone, we're gonna always dot append, right? We're gonna always append into a stack, and then we're gonna check. I'm gonna say while stack and stack top equals popped. Where's my j? Where is my j? This is my j. It's not a count, it's the index. And if the same, right, then we say stack dot pop and j will increment. And keep doing this when I return j and equal to len popped. Will j be overflowing? Not likely, because the most j can do is the same as the p. J is not going to overflow. So let me try. Yep, it passes everything. So I like this solution better because it's shorter. Yeah. Try this one as well. It shall pass with no problem. Okay, oh, this one is faster. I mean, it's only a couple milliseconds. I shouldn't even mention. All right, so this is the official solution. It views the problem from the perspective. More room. Perspective. Oh, we do not have more room. Of pushed instead of popped. From a design point of view, this is clearly the better solution because it's cleaner and shorter. You can mention we run it at still O, now become O put. Why should I say ON? Because we have this here. I just realized. Why say P? It's O. It's the same. Push and pop is the same. The same length. ON, it run at 68 milliseconds or 84% ranking. Alright, the last solution. The last solution is from some guy mentioned by Leet215. So we're gonna write this O1 space. Use pushed as the stack. I have thought about it, but was not able to come up with a good scheme for it. This O1 solution was from the post in Leet215. So we need to cite here. I'll just copy the link. All right, let's try to code it ourselves. So what we're doing is we say every time we push. So every time we push, instead of pushing to a separate stack, we're pushing inside. And then with the push, we're going to use an I. So we need to have I, J, we can use this syntax. And then we're going to say for P in pushed. So every time we're going to push, how do we push? We say pushed I is going to equal to P. And then we say while what? While I is larger equal to 0 and pushed I, so that's the top of the stack. So we say I is the top of the stack, is equal to popped J. Then we do I minus equal 1, J plus equal 1. When we're done, so we put pop, 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 and we need to increment I again because I currently is I currently must be remaining on the next possible spot for the push. So I have to be increment here, and we're gonna return what? J equals len popped or I equals 0. Yeah, I equals 0 because if it's all good, then a stack should be empty. When a stack is empty, I is pointing to 0. And we're gonna go 3. Passes everything. Copy and paste it in. It's our last algorithm that we're gonna look at today, which is pretty brilliant. Go submit it, and we're good. Wow, this one isn't fast. But if you look at the memory usage, right, it's all one, but because the input space is too small, so it won't show too much here. But this one does have the best runtime because only thing we did is assignment. Yeah, there's no push, no pop, so that saves time, and we didn't even call land, so everything is very static. Just one loop, just two loops, and a few. What is this called? A few checking, and that's it. Oh, when this one we get at 64 milliseconds, 94%. Right. All right, that's it. Very simple question, and we had 3 different solutions. I am happy with this performance. And with that, I am going to end for today. It's a fast one today, and I did it early, which is good. We're going to see you guys tomorrow, weekends. Let's see if we're going to get a difficult one that can bog us down to 2 hours. We'll see that tomorrow. Bye. Adios.